reflections. So a reflection for you guys was a flip when you guys were younger. You would just like flip it over something, right? So reflections just flip things over. So you're going to be able to, you can identify the lines of symmetry and you can perform reflections. So that's what we're going to be looking at today with this one. So a reflection is a transformation that moves a figure, the pre-image, by flipping it across a line. The reflected figure is the image. So remember I was saying like the original and the transformation in the last one? So the pre-image is the original, and the image is the transformation. So know those vocabulary words, pre-image and image, because on your quiz that you'll take over this stuff, which might be Monday, I'll let you know Friday, Monday or Tuesday. I know, just like constant testing. There will be some vocab on there. So I said rigid transformation on the last one, right? So a rigid transformation means it doesn't change its size or shape. Pre-image is the original. The image is what it becomes, okay, after the transformation. Pre is before it moves, right, basically. So a reflection is a transformation that uses a line like a mirror to reflect an image. The mirror line is called the line of reflection. So also know that the line that it's reflected over is called the line of reflection. Know that a translation is a sliding of points and a reflection is a flipping of points as well. These are all words you need to know. So if you notice that this is the line of reflection, if you folded your piece of paper over that line of reflection, the two dots would land on top of each other, correct? You guys all see that? That's what that means. Take your piece of paper if you need to and fold it, and you should see that the two dots would line up on each other if you folded it over this line here. This line is the line of reflection. And these little marks here just mean that this is congruent to this part. That's all that that's saying. All right, so let's get at this here. So graph triangle ABC and its image after the reflection over the given line. So we have A, B, and C there, and the reflection line, this is the line of reflection, is y equals -1. Okay, so y equals -1. You guys have to remember this stuff from Algebra 1, which can be difficult for even you guys in Algebra 1. Who remembers what kind of line is drawn with a y equals equation? Brandon?
Horizontal.
It has to cut the y-axis so it's always horizontal. So this is a horizontal line. If it's x equal, it'll be vertical. You might want to make sure you keep your notes out and write this down so that when you go to draw the lines of reflection on your notes tonight, you have that, okay? So I'm going to draw my lines of reflection with dotted lines. So at y equals -1, I'll erase the lines. I have one there. And I'm going to just make it dotted so I know it's my line of reflection. So this is the line that I'm going to be reflecting over. Yeah. What? If you mark Cameron's paper, so help me. All right, so plot your points. So A is 1, 3. B is 5, 2. And C is 2, 1. And then you're going to connect in that order. Okay, so here's how this reflection is going to work. How many away from this line is A? How many away from this line is A? Which one is it, Hannah? Thank you. So it goes 1, 2, 3, 4. So how many past the line do you think we should go? 4. 1, 2, 3, 4. It's reflected in the exact same position then. And you use that little prime thing to say that it's the image. So remember that red, or the purple, sorry, is the pre-image. And this is the image. So if C is here, how many away from that line is it? 2. So where would it end up on there? What would the ordered pair be for C then? If it's 2 away here, where would the ordered pair be? Yeah. 2, -3. Madison? Are you okay back there? Huh? Yeah or no? Okay. So we're just reflecting it. So if I could take my board and I could fold it over on that red dotted line, this point should line up with that point. And this point should line up here. So I'm just doing the exact distance from the line on both sides. So do you see how the distance here is 2? Yeah. So that distance has to be the same over the line. Okay. So where would B end up then? What would the ordered pair for B become? What? 5, comma, -4, but yes. I think that's what you meant. So if you notice, if you were to fold your piece of paper over, those things would line up. You not seeing that? Okay. So A prime is at 1, -5. B prime is at 5, -4. And C prime is at 2, -3. So tell me something you notice about these ordered pairs. What is something you notice about the original and the new one? What do you guys notice about the original and the new one, if it's a reflection here? Tucker? The X values do not change in the ordered pairs, right? So the X values do not change. Do you guys see that? Which makes sense, you're reflecting over the Y. So when you reflect over something that's a Y equals, the X values will not change. So that might help you out a little bit. You'll also notice that from 3 to -1 is how many? 4, right? So if you keep going 4 more away from that, that's at -5. It's kind of like the midpoint. Remember when we talked about midpoint and you had to find the end point? It's kind of that same concept, right? Except without it being an ordered pair. So from 3 to -1 is 4, so we have to keep going past that in the other direction. 4 more in that direction is -5. Do you see that? 2 to -1 is 3. We have to go past that. 3 more past that is -3. 1 to -1 is 2. 2 more past that is -3. Do you remember kind of talking about midpoint at the beginning of the year? That was like one of the first few lessons I taught you, actually. So that is kind of like what this is. Kind of, because it is the midpoint. That reflection line is the middle of the two pieces. So again, this is the pre-image, and that's the image. Just so you guys remember that. Are you making mistakes on purpose now? All right, next one. So x equals 1 is what we're reflecting over this time. So x equals equations. So this is the line of reflection, first of all. X equals equations are always what kind of line? Vertical. They have to cut the x-axis. So if you're cutting the x-axis, it has to be vertical. So that's just my line of reflection, x equals 1. And then I'm going to plot my original points. And this is the pre-image. Remember, pre means before movement. Okay. How would A change? How would A change on this one, guys? It wouldn't. If you're folding it on that line, it wouldn't move from that line, would it? So this would be A prime. Okay, what is the ordered pair for B then? Corey, what would the ordered pair for B become?
0,
0, 1?
oh wait, that's...
Oh, you told me C. I'll take C. Okay, did you mean, so C is 0, 1. That is correct. I'll have somebody else do B. So yeah, so C is 1 away, so you went another 1 away, right? Ben, where would B go? -3, 2. Okay. Which ones do not change in this case? Which values are not changing this time? Which ones aren't changing this time? The y, because we're reflecting over x. X is the one that changes. So the distance from 1 to 1 is 0, right? So if you have to go 0 away from that, it's just going to say 1, right? We're looking at the x's. 5 to 1 is 4. Going past 0 would put us at -3, right? Because 1 would put us at 0. 3 more would be at -3. 2 to 1 is 1. 1 past that is... Did I write the ordered pair wrong? Can somebody please yell at me next time? That should be 0. Where did that 2 even come from? Where did that 2 even come from? I don't even know. I don't even know. But that should be 0. This is why we're checking things. So your C value should be 0, 1. So if you don't have it at 0, 1, make sure that's fixed. I have no clue where the 2 even came from. I think I gave you this one instead of the. I think I gave you the pre-image instead of the image point. All right, questions there so far before we do the next example? All right, if we're reflecting over are we on the x-axis? Is that right? Is that the right example? So I'm going to draw a line along the x-axis there. That is my line of reflection there. You have to graph it every time.
No, I mean label.
On the graph, yes. It's really good for you guys to get in that habit. Okay, then go ahead and plot your points, your pre-image, 2, -1, -4, All right, so let's reflect it. Z is here. If we reflect it over the x, where would it go? What? 3. 3, -2. Where would x become? Dylan, where would x go?
Be negative, or it would be -2.
So it's going to be right here? It's reflecting over this, so you're folding it on that. So if you folded this piece of paper right here,
It'd be
2 comma,
1.
there you go. Ayana, how about the letter Y? -4 comma. So what do you guys notice about this one? Look at this one here. What do you guys notice about the signs and everything on this one when it's reflecting over the x-axis? Melinda, you notice something?
It crosses each other.
They do cross each other just because they're on opposite sides. But what do you guys notice about the points, I guess is what I'm trying to ask.
The y-axis is like multiplied by -3.
Yeah, it's just an opposite, right? So the x-axis stays the same, but the y-axis just changes signs. I should say x value. If you can't remember that, that's not a huge deal. You can always plot it, but just something that we're noticing. All right, so the next one we're going to be plotting over the y. What do you guys think is going to happen on that one? If the x values stay the same and the y is opposite for the x-axis, what do you think is going to happen on the y-axis then? Yeah, so let's see if that's true. So Ayana said it's just going to switch the x and y in this sentence here. So let's see if that's true. So the y-axis is my line of reflection. If anybody needs help plotting points, please let me know. All right. Let's try to determine the the image points before we even plot them. So what did we say we think it's going to be? We said if this one's x value stays the same and y is opposite, we think it's going to be the y value stays the same and x is opposite, right? Is that what we're thinking? So let's see if that makes sense. So do you guys see that I just kept the y values the same and just changed the signs? Let's see if that's right. So -3, 4 would be s prime. So that's 3 away and 3 away. Does that one make sense? Yeah. Okay, -3, 1. It's t prime. That is 3 away and 3 away. Does that one make sense? 2, 1. So 2 away and 2 away. Same distance again. And 2, 4, which is v prime. And they're 2 away and 2 away. Is anybody lost at what I just did there? Please raise your hand and ask a question. Do you see how I just did it with a rule instead of like counting? If that doesn't make sense, count. I don't care. I'm showing you more than one way so that it makes sense for all of you. So yes, they do overlap. It's okay. Right, so the last reflection is over y equals x. So we'll look at that last. This one you're going to kind of have to remember a rule for. We'll see if we can figure it out though. Who knows what y equals x even is? How do I graph the line y equals x? What is my slope and my y-intercept? Yeah.
The y-intercept is 0 and the slope is 1.
Good. The y-intercept is 0 and my slope is 1. So I start at 0, 0 and I go up 1 over 1. This is known as the parent graph of a line, just so if you don't remember that from last year. Okay, if you're like eyeballing this like diagonally, I'm going to start with just R, I'm not going to plot any other points, but if you eyeball this diagonally, do you guys see it's like going diagonally to the line? And we eyeball that over, it looks like it's going to be down here at 2, negative 2. So let's look at those ordered pairs real quick before we do any of the other ones and see if you guys can figure out what just happened there. What just happened with your ordered pairs? Dylan?
You reflected off the y-intercept, the 0, 0.
Yeah, you do reflect from 0, 0. That's true. What else?
Like, they both flip, like, change their signs.
Okay, that did happen. But what more specifically? Let me give you another one. That did happen on this one, so that one's a little bit confusing. Let's do S as well then. 5, 0. Which is right here, okay? What if I tell you the point is here for S? Prime. What happened?
Like the X and Y numbers just switch.
Yeah, so I understand why you said that, so that's why I had to do another one. So do you see that X and Y just switch? Okay, so X and Y are just going to switch because you have to go back to 0. So somebody said something about 0. Who said something? Dylan? You did? So you have to go to 0. So you went 5 to 0, and then you have to go 5 away so that when you fold it over, they'll be on top of each other. Because if you just went over here, would they be on top of each other if you folded it over this line? No. If you're looking at it like this, this is through this line here, so it has to be up there kind of like that. Okay, so what do you guys think the ordered pair of that last one's going to be then before we even plot it? Brandon.
-1, 3.
So I have 3, -1 for t and -1, 3 for t prime. Now I got to connect these correctly because I used different colors, so this is going to be really confusing. So R goes to S, which goes to T. Okay? And that reflected to become R goes to S, which goes to T. So you see if you folded it over, it would create that wonderful shape that's happening there. Right. So the last slide there is just the rules. So if we have already determined these, right? If you are across the x-axis, we said that the x stays the same and you just change the sign, right? If it's across the y-axis, y stays the same and x sign changes, and y equals x is just the flip. All right.